you've been allocated. So now without any further ado, let's move on to the first speaker, Marina Galindo, who is an industrial engineer specialized in energy techniques, and she has a master in international business administration. Her professional career has taken place in the fields of renewable energy and energy efficiency. She works as a senior manager in Tilia, which is a German-French consultancy firm that collaborates with companies, with public agencies, and some industries in energy transition projects with the aim of optimizing water and energy use. In Tilia, she's been working a number of energy transition projects in France and also within Europe. In those projects, she works in energy coal and heating projects. Since 2016, she participated in a number of projects for the EU, including the one that she's going to share with us this morning with us. The name of her presentation is Integration of Renewable and Waste Energies in Heating and Cold Networks, European Vision and Best Practices. Marina, the floor is yours. Let me play the PowerPoint as you make your presentation. Hello, good morning. Thank you very much for Madrid Subterra for your invitation. Thank you very much to the University of Madrid too for the geological faculty. And thank you to all the participants who are here with us this morning, and also those who are with us online. As the doctor was saying, I work in a French-German consultancy firm specialized in energy transition. We work mostly with city halls, public agencies, urban development agencies, utilities, and certain industries with the idea of developing and implementing their energy transition projects. Focusing on a number of things, including waste energy and renewable energy. And we've seen that when we look at a local level or metropolitan level, many times the best solution are the heating networks that use local energy or heating sources, renewable or waste sources, basically. I've organized my presentation based on two blocks. A first block that deals with the key role of heating and cooling networks in the EU, and what is the existing situation of the different heating and cooling markets within Europe. And a second part that has to do with best European practices that we've analyzed in a number of projects. This is something that we did within the framework of a European project, such as, for example, the case of the Paris-Saclay project in France, and also some conclusions that we can extract from the analysis of these best practices, which can be replicated in other territories, such as Madrid. I'm going to start with the European policy. As you know, Europe plans to be carbon neutral by the year 2050, also in the Green Deal at a European level. And last year, within the EU package, as I was saying, the target was to reduce 50% the heating and cooling within the European framework. To achieve these ambitious targets, to decarbonize the thermal heating and cooling demand is a must. And nowadays, we're still kind of far from achieving that. The latest data that we've seen suggests that at a European level, we are at a percentage of 23% of renewable energy use. In Spain, we're under 20%, but in some countries, they're really doing a pretty good job. And there should be a reference for all of us to try to find some inspiration, because in Sweden, they have 66% in the use of renewables relating to the H&C demand. So yeah, mostly Scandinavian countries are the ones that are performing better, and also the ones in the Baltic region, where their percentage is above 50%. 50%, above 50% that is supplied with renewable and recovery sources. These are also the countries where the heating sources have a greater market share, about 50% or more. In Denmark, for example, even more than 60%. This awareness, the need to decarbonize energy demand is increasing, but it's still kind of limited at European level. For more than a decade, all the energy policies have focused on electrical renewables for a number of decades, and only the EU presented the first communication on the need to decarbonize the thermal demand in 2016. It's kind of recent. What we can see is that if we want to accelerate this kind of energy source, we need some subsidies and support so that we can contribute to remove some of the barriers that are being encountered by some of the local authorities and even the citizens in the decarbonization of the energy demand.
Como en muchos otros campos también es que faltan datos.
Like in many other places, is that there is a lack of knowledge about how we heat our homes, how the warm water reaches our showers. That data gap, as we call it in English, can also be seen in other fields of our society. And that's what we have tried, what we have been working on in my company, we together with the European Commission, to try and explain how this works. Using renewable sources, what is the situation in each country, because the level of acceptance is different in countries. In some countries, we have lots of information. In others, we have hardly any information. If we look at the statistics on the gas and electricity sector, it's totally different. And this is necessary because in order to be able to carry out specific policies, we need data. And the political players need detailed information. So in my company, we started working in 2016 with a joint research center, which is the scientific directorate of the EU Commission, and that fits the DGM, which is the energy directorate responsible of carrying out all the energy sectors in order to propose changes. So first of all, we carried out 2 studies, which are public studies, which are in the presentation. I've included the link in Google on best practices, each of them with 8 different cases, which are quite diverse, and that you'll mention later on in 2016 and in 2021. Later, we did another study for the Energy Subdirectorate, together with some of the scientific centers that are more prestigious, such as the Kapferer Institute in Germany, the ECO Institute also from Germany, and the Technical University of Vienna. And the person responsible for heat networks in Europe called it the encyclopedia of heat, because it really gives a very comprehensive overview of the heating networks in the different countries, with the political situation, legislation, and also technical information about the technologies that can be used in order to integrate renewable and recovery and waste energies. Today, the heating network is about 12%. It covers about 12% of the heating market in Europe. And the awareness on its advantages is still very small. It depends on the different countries. As we can see in this graph, we can see more or less what's the main infrastructure or the type of systems, heating systems used. The most important for the different countries. In yellow, we have individual solutions using fossil fuels. In green, a gas grid, basically central heating in a whole building. And in purple, we can see the countries where the heat network or the district heating grids are the most important, especially the Scandinavian countries. And what's the advantage of these heating districts, or district heating, sorry, and why should we focus on that technology? Well, what we can see is that district heating and cooling combine different levers for decarbonization. And that makes them very powerful because on the one hand, they can integrate several sources of local and renewable energies. The first district heatings use biomass, but we can see more variety now. We can see also that they integrate geothermal, solar energy, aerothermia. They are very focused on buildings so that for the grid to work properly, they need to use energies using a low heat. Buildings need to be efficient, so it's very necessary to combine district heating with very well insulated buildings so that we can use low heat sources. And then in more advanced countries, these technologies, such as in the Scandinavian countries, this district heating is a very flexible infrastructure that can adapt as time goes by and adapt to the new technologies or new sources of energy without that affecting the individual consumer, because everyone at home can have its own heating, is not affected, but they can adopt new technologies. And what at the beginning where coal plants or natural gas plants will be replaced gradually with other sources, and we'll use different systems. And what we can see also in the more advanced markets, such as the Scandinavian countries, is that there's a lot of potential for synergy between the heat grid and electricity. For instance, they are providing a lot of flexibility to the transport network. So in a context where there's going to be more intermittent electricity, these associated thermal sources can add flexibility to the grid. I'm unable to go to the next slide. In this slide, I just want to present the situation in Europe. The study that we did with the research centers in Europe, what we did was to create a tool, an online tool that is free. You can freely access it through the link that you can also see on the publication, where you can see all the different data that exists on the heat grid, on the heat grids across Europe, as well as the UK, Ukraine, Norway, and Sweden. It provides a more technical view of the volumes, the heat volumes that go through these district grids or any other grids, how the heat is produced, what are the different technologies used. Over 60% is used by CCTTs and using mainly fossil fuels, mainly natural gas. Also, as part of this study, we looked into the link between what we called district heating building nexus, which is the link between the energy efficiency of the building and that heat grid, and how we can do urban planning in a district and how it can be a great tool to develop those type of networks. We also looked in each country what was the market structure present, what type of cities we have, what type of cities have district heating, what type of shareholders do the operators have. What we could see is that, for instance, for heat grids, most of the countries not only have grids in large cities, as you could imagine, but they're also present in middle-sized cities or even rural areas, as well as large cities. And with regards to the shareholders and governance, most of the grids that we have in Europe are publicly owned. And although some of them, about a third of the countries, have a mix between public, private grids, PPPs, or even cooperatives, such as in the case of Denmark, a case that will be presented by the next speaker. With regard to how the consumers perceive a good working grid, basically what the study concludes is that they want transparency of prices, high quality of heat. They want very few interruptions, obviously, and a good customer service, obviously. So this is a very large study about the heating and cooling grids in Europe. It has mainly 3 different sections. The first one is the market overview. And then we have one more specific on regulation, and a third more technical block about the technologies that can be applied, the technical and economic conditions that we are designing for that heat grid, and some study cases so that you can see how we're using those technologies. In the end of this extensive work, we made some recommendations, high-level recommendations, without going into too much detail about what could be the good practices that could be proposed across the EU to have sustainable heat sources. Amongst them, as you can see, development of district heating and cooling, also financial support, direct or indirect, direct through a tax on fossil fuels, incentives to remove taxes on a non-recovered waste heat, a reduced VAT, as we can see in France, for the grids that use mainly renewable sources or renewable waste energies. Also, direct financial support to the investments in order to develop those systems. And a fourth item, which is one of the most important ones, in my opinion, which is mainstreaming strategic long-term local urban heat planning. I mean, we have to do it in an early stage of urban planning, otherwise it will not be able to be done. And it will be a lost opportunity we can't actually afford. There are other practices, such as imposing a renewable share, or also a long-term view, and how different companies are going to, and as well as the local entities, are going to contribute to the carbon neutral future. Incentives to facilitate the use of waste heat, such as the heat coming from data centers, from underground infrastructures. All that heat is getting wasted when we could use it, and we should offer incentives to facilitate that their use. Also, the end users should be more involved. There should be a fairer, what we call energy communities, and also greater transparency, because we believe that, I mean, we know, in order for us to be able to do this work, we had to call a lot of people. We had to, it's not easily accessible, that information. It's not easy to obtain that information. The second part of the speech will be focused on the best practices. What's most interesting about these EU studies is that they are very specific. We can know exactly what, I don't know, Barcelona has done to develop its district, or Tani, which will be introduced by our next speaker, what they have done to develop a grid that has a 91% of renewable and waste energies. So for each of these over 25 case studies, in just 8 or 10 pages, you'll be able to understand clearly what is the national context in which these case studies were designed and what's the local context. Is a general overview of the grid, also the governance business model, which is quite diverse. We try to have a very representative group of what exists in the EU. Also the technical solutions that have been implemented, what type of renewables and waste energies have been used and how much did they cost, how they were structured. Going into a lot of detail. We also try to identify if we have managed to create synergies between sectors, for instance, the thermal sector and the electricity sector, between different utilities, waste, water, transport, energy. There are a lot of synergies that can be used and valued thanks to this district heating. The future for each grid, and finally, a presentation for urban planners, local entities, governments interested on energy transition about each of the cases and what were the players that made it possible to reach those percentages of decarbonization that were so incredible. Most over 50%, some reaching 98%. What we can also see in this summarized table is that we have different countries with different climates, so we can lead to the use of district heating in all geographies. We have from all sizes, from 4 megawatts in Mieres in Asturias to 3 gigagrids in Copenhagen. I think what's also very interesting is to see that most of these districts grids combine renewable and waste energies. When we talk about renewable energies, it's not just biomass, which is the situation in most of them, but increasingly more, we see other types of sources, energy sources. Renewables for electricity, geothermal, biogas. And in both cases, both for renewable energies or waste energies, we can also include thermal, being able to use the local energies as much as we can. It's like waste energies, we don't talk only about incinerators, which could be the oldest model, but also about recovering heat from the London Underground, for instance. We have it over here, or from other industries such as data centers that generate a lot of heat, cogeneration or CCGTs, from any installation that needs to cool, not just for heating. So I recommend, if you're interested, have a look at these study cases, and you can see specific countries and specific technologies. It allows us to see very comprehensively what is district heating and how they were created and how they have evolved. I'm not going to present one of the cases as an example. This is one in which my company worked on. I think it was about nearly 10 years ago in France. I would like to present the framework, the support framework to these district heating networks in France. because France, in its 2015 law, put a clear bet on decarbonization and district heating, and it wanted to multiply by 5 the amount of renewable and waste heat and cold to make sure that at least 65% of renewable energies and waste heat was being used. So we have now about, well, the heat market is supplied by those district heating. Those grids are mainly coming with, mainly being used using renewable energies. And you can see 43,000 buildings are being heated in this manner. There are a series of measures that are complementary and that go from the reduced VAT of 5% for those that use over 50% of renewable energy to more traditional systems of incentives for the cogeneration plants to make sure that they use renewable sources. And also the STAR measure, we could say, which is what is called the heat fund, Réseau de Chaleur, that's provided 3 billion euro of aid in order to move to 11 billion of infrastructures made. This is the ANEM, the equivalent to the INDAE in Spain, the National Energy Transition Agency in Spain. And thanks to those subsidies, well, the French state can see exactly what type of grids are being developed, where they are, what type of technology is being used, what are the hindrances to their development, because everything goes through the fund. So obviously, in order to have access to the subsidies, you need to give information, and this gives greater transparency to the whole grid sector.
De este programa es
Something that I like very much about this program is that on the one hand, it imposes a procedure that makes a lot of sense, common sense procedure, but maybe if they didn't establish it, people wouldn't do it. And that is, how do I erect a building? How do I develop my district or my city with the aim of reducing my carbon footprint, my thermal carbon footprint? So first, you need to start by reducing consumption. Once you've worked at a building level, then you can mutualize the supply structure. To do that, you can connect to an existing network that is not very far. If that network doesn't exist, you have to analyze whether you could create it. And if not, you will have to look for an individual solution that uses renewable energies. Which renewable energy to use? How to prioritize them? First, you will use what cannot be delocated, and that if that heating network didn't exist, you couldn't put them into value. And that's the waste energy network. Yeah, residual heat recovery from water, from data centers, from incineration plants, from the subway, as we will see. Then non-delocatable energies such as geothermal, which if it's not used by a heating network or by an individual facility, that local renewable source would be lost. And then lastly, energies that can be created and that can be brought from the outside. And we're talking about here about solar energy, biomass, gas. So this is a good method to optimize resources and use available resources as well as possible. The third pillar of this French strategy is the role of the municipalities, of the city halls, of the metropolitan areas. These municipalities, at the end of the day, are responsible for organizing energy within their territories. They're responsible for their energy policy that should contribute or that does contribute actually to the national energy policy. And that's why they have to propose measures of how they're going to achieve the targets that have been set. And many times that's how they develop these heating projects. Many of them are their ownership are owned by the actual cities or the municipalities, and many of them are managed by the granting of some national agents, maybe for 25 years, for 30 years. The one in Paris is going to be renewed in the short term, and it is actually almost 100 years old. But the normal period is about 25 to 30 years of granting. This is the project of Paris-Saclay, which is a project of urban development project that is being developed about 20 kilometers south of Paris. Before, they had the Polytechnical University, which is the most prestigious in France. The origin of this project was to face the large universities from the United States. The French, saw that they had very good universities, but they were too small because in the Shanghai ranking, amongst other, they couldn't thread the position of the giant American universities. So they decided to create a hub in the south of Paris, where they had the most prestigious university, to bring all the main engineering schools to that hub, the main research institutes to the water agencies, some of the main companies in the field, and to create this within a framework, a sustainable. This is a project that was developed with more or less around the same time as the 2021 Paris Accord, Paris Agreement. And they didn't want to limit this just to the university or to the educational world, but also to bring other stakeholders to make sure that this hub could, or the country could be positioned as a country that was responsible, coherent in terms of their discourse on the speeches that they were, delivering in different parts of the world. So this is a project that was launched in 2015 that should continue until the year 2030, in which all these large universities are having a center there. There are also university fraternities and sororities for anyone that wants to set up there. There are also mobility projects for access improvement. And this is all done within a framework of innovation. They're trying to apply innovation to urban development. This is a project of general interest, which means it's a strategic project for France. And that allows them to go much faster, to have more support, to have more subsidies. And to roll this out, they created an urban agency that is called EPAPS, which stands for Public Urban Development of Paris Saclay. So in Tilia, we work for this institution, for the PAPS, which has as one of their main projects the heating and cooling geothermal network. There are two main districts, the École Polytechnique district and the Moulin district. Each one of them has like a mini grid, a mini network. One of them equipped with a hospital, and they plan to have a third network that will be, and all the three networks will be interconnected. But right now they only have two of similar structure. This is the concept for each one of these individual interconnected networks. There are three mini interconnected networks, as I was saying. Firstly, there's a centralized geothermal generation that valorizes our resource at 30 degrees of temperature, 700 meters of depth. This resource is driven to a loop at 30 degrees that will distribute that water through different substations where you have heating pumps that will be able to increase temperature, and then from there they will distribute that water to all the new buildings that are highly efficient. So the distribution rate is about 65 degrees of temperature and 45 for the return line, and for cooling is 6 degrees and 12 for the return line. Also, something unique about this network is that you can have different operation in different networks, and also depending on the time of year, and also depending on whether the heating or cooling demand is high or low. So they have like an optimal operating mode, which is what they call the mid-season, and that's in spring and autumn or the fall. And during those two seasons, there's an exchange between the buildings and the 30-degree loop that enables an optimization of this geothermal source. In the winter, they need more temperature, so there will be an additional energy source that will be provided by gas. And in the summertime, since there's more demand for cooling than for heating, what you need is increased cooling, and what they do is to extract more calories, and that's why you have a higher rate of cooling in the summertime. In addition to the thermal design, what I think is very interesting about this project is the business model, how this was developed so that they could best distribute the risks amongst the different stakeholders, public and private. The public-private partnership model that was used is what is this called, this kind build and operate. This was an agreement that was awarded in 2015 until the year 2022 to a private consortium. And right now there's a second phase in which a similar contract will be awarded, probably pretty much the same consortium. The difference between the different classical concession and this model is that the public player, in this case, the Urban Development Agency, is the one that will be make the investment directly, the one that undertakes more business and billing risks, and will make or will sign the final agreements with the clients. So this is a new business model that has been used in the latest projects. I was in Barcelona, for example, with the Just Barcelona project, and their network had a lot of problems because when they had all their business model fully developed, the financial crisis came in 2008, and those buildings were never built. For a private stakeholder, it is very difficult to undertake all that risk. So what they did here was to say, all right, let's divide the project in different phases. As the project moves forward, risk will decrease, and maybe we can look for a different model. When there's more risk is when they have to start the project from scratch, and that's when all the different promoters and developers have to come up with their ideas for a building and then see how things work. That's why they decided to structure this project into different phases. What the PUPs, what I mentioned earlier, the Urban Development Agency, basically is responsible for planning, for the entire planning of the urban development project, and to allocate the different lots to the different players. Once the lots have been assigned, then they have to make sure that the way the buildings are erected is compatible with the actual heating network. All the monitoring system is implemented to make sure that later the grid operator can confirm the efficiency of each one of the substations linked to each one of the buildings. And that allows the project to be developed in a coherent manner, in a consistent manner. It also provides the grid operator with some visibility as to what are the kind of buildings that are going to be erected, what is going to be the type of demand that they're going to receive. And another advantage of this heating network is, one thing is theory and the particular calculations you can make on a piece of paper And another thing is the actual reality of life. So with these heating and cooling networks, you can compare the theoretical calculations to the actual demand. And if a building demands more and another building demands less, then you can compensate. This network was developed as a geothermal project, but as things moving forward, the geothermal resource is limited. So the more consumers you have connected to the grid, the geothermal source has a greater risk to go under 50% of renewable. That was the target. So what they've done is to integrate the other renewable sources, all the recovery sources, more specifically a particle generator waste recovery source. That is actually what they're using now. In addition, the heating and cooling source of Paris-Saclay is part of a European project aimed at developing new models so that these HNC networks can interact better with the power grid and to be better integrated in terms of demand response. This project is the one that you can see here on the screen, and they're going to be working on this until the year 2024. And to conclude on this particular project of Paris-Saclay, the key success factors were a natural structure that could support this type of investments to make sure that they're viable. Political support at a local level that has to be there because we're talking about a strategic project at a local, but also at a national level. A heat and cooling system that should be developed as part of, as an integrating part of the urban development. Also, a flexible organization. This is something that I didn't explain before, but the public agency is also supported by a number of consultants, which is my company, and also legal advisors and engineering advisors to make sure that they can manage their work or their efforts, especially when it comes to more technical things. So in that sense, whenever there are more technical or legal aspects that need to be assessed, they can collaborate with the consultants to clarify the course of action. That's something that we do. Lastly, as I was saying, a modular architecture, both at a technical and constructural level, that makes it possible to move forward and to adapt to the circumstances as things change. To conclude, since this Paris network provide us with a number of lessons, what we've done is to reach a number of conclusions of lessons learned of what can be done to make sure that we can replicate these kind of networks in other places at a European level. So the conclusions are the ones you can see here. 5 main blocks of conclusions. The first one is related to the implementation of a comprehensive and coherent set of policies enabling or making it possible to establish decarbonization targets, and also to explain how that is going to be carried out. And also that can help or contribute to removing some of the barriers that are encountered by some of the stakeholders in the development of heating and cooling networks. For example, nowadays, it is not always, energy planning is not always part of urban development. Some construction codes penalize the use of heating and cooling networks. Waste sources are not considered as renewable sources in many countries. And when these networks contribute to make the power grid more dynamic, they don't always see the benefit of having a reduced tariff that can kind of position them better on the marketplace, and that kind of recognizes a contribution to the energy grid. Also, it needs financial aid to make sure that they can be further developed, especially in less emerging countries such as the Spanish market. Second group of recommendations is related to the promotion of governance. What we've seen is in the promotion of participative local governance is key to the success of many of these networks. The municipalities, the districts, the different energy producers, waste energy producers, all of this can be integrated and actually should join this type of projects because it would help the development. There are also ways of public-private partnership that have evolved, and now we're moving towards a real, actual partnership in which the role of the public sector can be a role of reinforcing the project to make sure that the project can move forward and the strategy can be under the control of the public agencies. And some of the digital solutions that are available nowadays allows consumers to have more power, and that allows them to contribute to the actual efficiency of the system. For example, the smart meters make it possible to have better tariffs that encourage more effective and efficient use of the grid and of the system, because if that's the case, people are going to go for these tariffs.
As I have said before, we need to go towards a more integrated position of the energy systems. For that, it's important to have better planning and to focus on urban planning. There are many synergies that can be very valuable in these stages between different services and also between the district grid and the buildings. And here are more technical issues that are also important. One thing is to know what are the available sources, but we also need the optimal mix for every specific case. So we need experts or people that are able to integrate different functions and that can develop a long-term view. You can also see that district cooling is not spoken about so much, but we should talk more about it because we are going to need increasingly more cooling. And district cooling has many interesting and positive effects from an environmental, and it can also contribute to the flexibility of the electricity system, much more than individual solutions, obviously. To conclude, the last group of factors for this success of this system has to do with, well, based on using technical data to create a business case, how to make a business case that can be financed and that can be put forward. And I think that the different case studies analyzed can help to give you some ideas about how there are, in different situations and with the different local entities, made it possible to move forward with this project. Some models are more innovative when we look at the best practices, for instance, in terms of tariffs and tariff structure, making sure that it represents the cost. We could also have different tariffs for the different seasons, as in Paris-Saclay. And we can also use these tariffs to make sure that consumers consume more responsibly or are more concerned about the footprint in their building, thanks to that, those incentives, and that will contribute to the efficiency of the system as a whole. In some cases, especially in the Danish case, and I think the next speaker will talk about it, what we can also see is that more participatory governances, such as energy communities, are increasingly more present. And they mean that they make the system fairer, that the different costs and benefits of the systems can actually be perceived by the consumers and the energy communities. So in the end, it's a win-win situation. So thank you very much. Thank you for your attention. If you have any questions, it'll be a pleasure to answer.